Happy day students, today we are starting a new topic called electrostatics. Okay, and in this topic you can see that the word is electro. Electro means is electron over here. Okay, statics means at rest. So this means electrostatics is electron at rest. Electron at rest. Okay, and here electron actually meaning is charge. There is charge at rest. Okay, so in this particular chapter, we are going to study what are the effects of the charge when it is at rest. Okay, but before going to start further, we would like to know that what is the meaning of the charge. What charge is actually? Okay, it is a basic property or not a basic property? So we would say that charge is basically not a basic property. Why? Because we know that there are certain objects which are not having charge. It's not necessary for all the objects to have charge. But do they have mass? Yes. So mass is the basic property. Okay. All the particles, all the constituents, however smaller the particle is which is existing, must have mass. But it is not necessary that those particles have charge. So charge is not a fundamental property. Okay. So first point is, it's not a fundamental property. Not a fundamental property. Okay. Now, we decided it's not a fundamental property. Then how the charge will come? We have written here electron, and from electron we have set that charge. That means electron definitely must be having a charge. Okay. So through experience or through the experiments rather, not experience, we have found out that the charge on electron is found to be 1.6 into 10 to the power minus 19. Okay, what is the unit of the charge? Unit of the charge is coulomb. Okay, so charge on the electron is positive or negative? Negative. Charge on electron is negative 1.6 into 10 to the power minus 19. Same way, charge on proton. Charge on proton is observed to be plus 1.6 into 10 to the power minus 19. Okay, these are the charges on two basic particles. What are the masses of these particles? Do they have mass? Yes, Yes, they have mass, because every particle, every object, every constituent is having mass. What is mass of electron? Mass of electron is 9.1 into 10 to the power minus 31 kg, and mass of proton is 1.67 into 10 to the power minus 27 kg. Okay, these are about the basic particles. Now, whether it's a scalar quantity or vector quantity, charge is scalar or vector? Charge is a scalar quantity. Why? Because there is no direction associated with the charge. It has nothing to do with the direction as such. Okay, so that's why we say that charge is a scalar quantity. Charge is a scalar quantity. Charge is a scalar quantity. Okay, then what is the fourth property of the charge? What is the fourth property of the charge? It is, if we want to have the charge, if we want to give the charge to any object, what we have to do? Because we already said that every constituent, every particle in this nature doesn't have charge. Suppose I take a neutral object. This is a neutral object. This neutral object, it doesn't have charge. Does it mean that it is not having electrons and protons also? No. Because we know that every particle is made from these basic particles, electrons as well as protons. Okay? So this is also having electrons and protons, but still it is neutral. What does that mean? It means is the number of protons in this one. If suppose there are n number of protons, this n number of protons are equal to n number of electrons in this one. So what happens? We know that the charge on electron is negative and charge on proton is positive. So when they add up, say Ne plus Np becomes 0. N into minus 1.6 into 10 to the power minus 19 plus n into plus 1.6 into 10 to the power minus 19, that is equal to 0. That's called neutral object. Okay, this is neutral object. Now, if I want to make a charge, what I have to do? Can I remove protons? No. Protons are inseparable because they reside inside the nucleus. You cannot take out the proton. But can you take electrons? Yes, because they are loosely bound with the nucleus. So we can take electron. Now suppose that we are going to take electrons from it. Suppose 3 electrons I have taken outside. I took 3 electrons. So now what is the charge on the object? Let us see. So we can say now the charge on this object is Nb, that is n protons, plus 3 electrons you have taken out. Earlier how many electrons were there? N. So now electrons is n minus 3 into E. This is the charge on the object. Now how much is this? Check. N into 1.6 into 10 to the power minus 19, that is charge on proton, plus n into E, that is n into minus 1.6 into 10 to the power minus 19. Why minus? Because it's electron. Here minus 3 E into minus 1.6 into 10 to the power minus 19. That is the charge on this object. Now see that this and this gets cancelled. So what charge we are getting? Minus into minus. That means plus. Plus 4.8 into 10 to the power minus 19 coulomb is the charge on this particular object. So if you are taking the electrons out, we are getting what charge? Positive. Why? Because in this one now number of protons have become more than number of electrons because you took out 3 electrons outside. If the same way, if I am going to give the electrons, forget about these 3 electrons over here, I am going to give 2 electrons to it. Then what will happen? The same equation I will be writing number of protons n and here n plus 2 because you have given 2 electrons to it equal to q. Then what change will come? N into 1.6 into 10 to the power minus 19 same plus n into charge of electron minus 1.6 into 10 to the power minus 19, that's also same, but here plus and instead of 3 here will be 2 because 2 electrons we are giving. So here what is there? Minus 3.2. So our answer here will become minus 3.2 into 10 to the power minus 19. It means when you are giving the electrons, the charge on object becomes negative, and when you are taking the electrons, charge on the object is becoming positive. Okay, this is fourth property, and this fourth property is called charge is quantized. What it is called? Quantization of charge. Quantization of charge. What is the meaning of that? Its meaning is you can only take or give the charge to an object in whole number multiples of electron. Okay? The charge transferred. Charge transfer from an object can happen only in whole number multiple of charge on electron. The charge transfer from an object is only possible in whole number multiple of charge on an electron. Okay, this is written as Q equal to plus minus Ne. Why plus minus Ne? That when you are taking the electrons outside, then the charge becomes positive, and when you are giving the electrons, the charge on an object becomes negative. Okay, is that clear? So then what is the next property? Next property you already have discussed. What is that? The unit of charge. What is the unit of charge? Unit of charge is coulomb. Unit of charge is coulomb. Okay. Then what is property next? Next property is about two charges. How many types of charges are there? That also we have discussed though. But there are two types of charges. There are two types of charges. Positive and negative. Okay, and positive positive repel each other, negative negative repel each other, and positive negative attract each other. Positive positive repel, negative negative repel, positive negative attract each other. Okay, positive negative attract each other. This also we have to remember. Alright, let's see another property. Property number 7. So suppose that we have an object which is a particular charge. Okay, suppose this is the object, isolated object. What is the meaning of isolated? Which is not in contact with anything. Okay, it's an isolation. Suppose that the charge on this one is like this. Suppose this is 3 coulomb, this is minus 1 coulomb, and here is 2 coulomb. Okay, inside this way the atoms are arranged, and these are the charges inside it. Now this we are churning, this object we are churning it. Okay, something happened, and because of this, then the charge in the same object is like this. Now you have to give me what is the charge over here. Okay, what will be the charge? So what to do? We know that we have nobody is in contact with this one. This is in isolation. So what will happen? Charge on this will be conserved. Okay, charge on an isolated object will be conserved. So that means whatever is the total charge here, same should be the total charge here also. So let's see how much is the charge over here. 3 plus 2, 5 minus 1. So total charge over here is 4. Okay, now you see here it's plus 4 coulomb plus 1 coulomb plus 5 is already here. So what will be here? Minus 1. Okay, now check the total charge over here. Here also it is plus 4 coulomb. Here also it is plus 4 coulomb. So what is this property? This property says that for isolated system, charge is always conserved. Okay, let's see the next property then. The next property is called invariance property. It says charge is invariant. What is the meaning of that? Charge is invariant. Okay, its meaning is when the charge is going to move with the speed comparable to speed of light. Okay, there are charges that we are going to see in quantum physics that the charge is moving with the speed of 1/10 of speed of light or 1/100 of the speed of light. Okay, so when charge moves with the speed which is comparable to speed of light, it doesn't change. It doesn't vary. So that means charge is independent. Charge is independent of speed of motion of charge. Okay, charge is invariant. But remember, mass is not invariant. Mass changes. If the particle is moving with the speed comparable to speed of light, mass do change. And if you remember, I have shared this formula with you before. M equal to m naught root over 1 minus v square by c square. What is c here? C is speed of light. C is speed of light. V is speed of particle, or speed of mass. And what is this m naught? M naught is mass of object at rest. Mass of object at rest. Okay, so if the particle is moving with the speed comparable to speed of light, then mass is going to change as v is changing. Okay, we have taken this kind of a thing in mechanics? No. Why? The reason being in mechanics, this v is very small as compared to c. So when this is negligible as compared to c, we can say that this will come as 1 only. So we always take the same mass. But in quantum physics, this will not happen. This particle moves with very high speed. So mass do change. Okay. So what is the next property then? For the charge, as we discuss all the properties over here, we discussed that the charge, two charges attract each other when they are unlike charges. Positive and negative unlike charges attract each other. If they are like charges, they repel each other. Okay, charge is invariant, charge is scalar, charge is quantized, charge is conserved. Okay, last property we have is, if charge is at rest, it produces electric field around it. What it does? It produces electric field around it. Okay. But if it starts moving, let's say with a constant speed, then what it does? It produces electric field as well as magnetic field. Electric field as well as magnetic field. Okay, because moving charge means current. Okay, current produces magnetic field around it. And if this charge is going with acceleration, that means speed is changing, then along with producing electric and magnetic field, it also radiates energy. Okay, it radiates energy along with producing electric field and magnetic. Electric field and magnetic. This property we have discussed when we were discussing polarization also. Okay, so these are the properties of the charge. Now I am going to give you a question based on one of the properties. What is that? Let's see. The question is, if I have to give 1 coulomb of charge to an object, okay, if 1 coulomb, let's say plus 1 coulomb charge is to be given to an object, electron has to be removed or electron has to be given to the object. Electron has to be removed. Okay, so what we have to find? If plus 1 coulomb charge is to be given to an object, how many electrons need to be removed from the object? That's the question. Okay, how to find? We already have discussed one of the property, which is quantization property, in which we have written Q equal to Ne. Why I am writing Ne over here? Because I know that the charge is plus 1. Okay, so here I am going to write 1, N I am finding, and here charge on electron. How much is charge on electron? 1.6 into 10 to the power minus 19. Here we don't have to keep minus. Okay, just put the charge on electron. So what's coming? N equal to 1 by 1.6 into 10 to the power minus 19. That will be 6.25 into 10 to the power 18 electron. So to charge one object with just 1 coulomb, how many electrons have to be removed? 6.25 into 10 to the power 18 electrons. So you can think of any object as having how many electrons. Okay, so that's all for today.